Let's start working with a more another example. Now that we understood the Windows APIs, how they are being called, the function convention, let's do some easy exercise so that you guys can get more understanding of IDA Pro, the assembly instructions again, and play with the debugger and with the IDA Pro in order to understand assembly code. Okay, so we are here in another example which is called find password, and here I'm gonna open it. Sorry, it's already open in IDA, and it is also already loaded in the debugger. So as I said, always the first thing you need to do is highlight the calls, go to your graph overview, and start kind of going through the whole function to have a better understanding of what's going on. You can see here that it is an enter password. Give you a clue that it is expecting a password, and then there's some loops, another loop there, we don't know, but after that loop is some decision. It says either this is a wrong password or congrats, you found the password. So basically, just by looking quickly, we can kind of understand that it is expecting a password, and based on the password enter, it's going to give us either wrong or congrats. That's it. So this is recommended so that you can have a quick overview of the functions. Because sometimes you will have multiple functions, more than 50 functions to analyze, and you don't want to spend time in every single one. This way you can focus on what it is interesting. Okay, so you might be asking, what is interesting? Well, always depends. Like sometimes you will focus on some APIs, right? Some APIs like socket related APIs to connect to internet, or create file API to create a file, or write process memory API to inject into a process. So once you have more experience, you will see which are those APIs. Also, you can always go to imports, and imports you can have a better understanding of the APIs being used and which ones you want to focus on. Okay, so in this case we saw the quick overview of main. We know that main, if we press spacebar, we know that it is loaded in the 40 base address plus 1000. So we can jump into the main function right away, as we saw in the previous class. I'm gonna do the same in the debugger. In the debugger, we are in the main CRT startup entry point. So we quickly go to the memory. We check the base address, which is AD0000. We click on C again to come back, and then we click on Ctrl G, and we go to 08D1000, right? Which means 00AD base address plus 1000. Click enter, and we go to the main function. Here it is already highlighted, but F2 disable the breakpoint, F2 again enable it. You click on Alt B, you can see the breakpoints being set. In this case it's just that one. We can right click on it and remove it or disable it if you want to reuse it in the future or edit some conditions. Anyways, so we're here, we press F9 to run all the program until that point, because we don't want to concentrate on the previous stuff as explained before. It doesn't matter, it doesn't make sense. So here we are, and let's step into it. Here is the mem set, and something that I want to show you in IDA. You can see here that this 3C and this 4C looks like two different values, right? But if you do an analysis, and that's the importance of assembly, to understand assembly, you will realize that this guy and this guy are the same. And for some reason IDA didn't display it properly. The reason is because IDA has some bugs in the free version, which doesn't count properly the ESP offsets, and therefore it's not able to understand that this guy and this guy are the same. But why those are the same, guys? Let's analyze why. If we get to the memset, again, if you don't know what is memset, you can go to MSDN and Google it. In this case, we can see the parameters. The first one is the destination buffer to initialize, the second one is the value to put there, and the third one is the size. Okay, but the first parameter is the destination buffer. If we click here, if we can see here, EAX is pointing to this value, and that value eventually is going to be called, right? You can see that after EAX is being set, it is going to be pushed as the first parameter, right? As you know, in reverse order, that was the last parameter pushed, which means the first parameter into memset. That value is the destination buffer. Eventually, we're going to read a password. That password is going to be saved into a buffer, which is expected to be that guy. Here in fgets, we have also a destination buffer, which is char. That char is going to be, in this case, pointed by ECX. Okay? The other parameters in fgets is, the first one is the destination buffer, the second one is the size to be read, and the third one parameter is where you are going to be reading information from. Can be from a file, or in this case, it's going to be from the standard input. In other words, the console. We're going to enter it via the keyboard. Okay? So, but anyways, here the ECX is supposed to be the destination buffer, and it is pointing to this guy. You see? This guy eventually is being pushed. That's the reason that I'm saying that since this guy is initialized, there is a buffer initialized here. And that buffer I don't see being used, guys. It's never been used. And how do I know? Because I don't see AEX being assigned to anything. It is just being pushed here, but this push, as you remember, after a call, EEX has a different value because EEX always holds the result of a function. So that means this EEX is different than this EEX. But anyways, we don't see a move EEX to something. We don't see that value assigned. In other words, we don't see this value being used. But this value should be the destination buffer. Otherwise, why you are initializing it, right? So let's confirm that in the debugger as usual. So we're gonna initialize a buffer supposed to be in EAX. Then that same buffer should be ECX, which is gonna receive the password. So let's do that. So we are here. We click F7. We start pushing values into the stack. As you can see, memset is ready to be executed. It is saying, okay, the destination buffer is gonna be this guy. I'm just gonna right click here and say following dump, so we can go into the memory to that guy. That's another way to jump. Also, we can always do it from EAX, also right click and following dump, or you can do DD EAX. Those are the three ways you can dump that specific address into the memory. Okay, so it's supposed to initialize that with 50 bytes with a value of 0. We click F8 and we see that it is 0. And the most important thing is write down this address, guys. BCFE8, A8. Okay, then it's gonna say print enter password. It's gonna print it into the console. We can see that here it prints enter password. Then it's gonna come and prepare the values for fgets. Okay, fgets, you can see here, guys, the ECX, the value that is the destination buffer, it is pushed into the stack, and that value is exactly the one that was initialized previously, as I told you. That confirms that IDA is not parsing properly, but again, if you use the commercial version, you won't have these problems. IDA should be able to label this guy and this guy with the same value, with the same name, sorry, so that you can say this is bar 1 and bar 1, and you can understand better, because if you get a bigger function, more complex, it's going to be more difficult to analyze. Okay, guys, so let's move faster. So we click here in F8. It is running, waiting for us to enter something. So we come here, we click on CSTT, you know, wherever you want. We come back. Okay, so here we see that it is the value enter, and then here's another thing. EAX is going to be loaded to a specific address. We click F7 to see the address, and that address is actually the same address that was initialized and the buffer. In other words, this guy here is also the same buffer. So these three red ones are the same variable. Okay, after that, guys, we can see that there is some initialization here. EDX is pointing to EAX. EAX, as you remember, is pointing to the buffer. We can put a comment here, like, sorry, if you click on semicolon, you enter comments, you can see here is EAX points to destination buffer, for example, right? You can click, and if you save it, you're basically saving an IDB. An IDB, which is the database for this analysis. So you can always open it and see what you understood. Okay, so EAX is pointing there, right? And then it is saying EDX is going to point to EX plus 1. In other words, it's going to point to the same address plus 1. And ECX is going to point to another buffer. Okay, so then here, guys, in this loop, after doing that, it is saying EAX, which is supposed to have the address of the password that we just entered. And actually, let me do this here. I say X points to the points to the buffer of password entered. Okay, a little bit more clear. Okay, so then here EAX is going to start copying its content into CL, and the reason we know it is 1 byte is because if you remember, CL holds just 8 bits. It is 1 byte, so that's it's telling us it is copying the first byte. Increment EAX, which means move to the next value. If it is test CL, if you remember, means are you 0? If not, then jump back to the loop, go to the next char, move it to CL, increment EX, it is 0, not, jump back. So basically here, guys, this loop is doing is just moving forward to all the values in EAX and incrementing EAX every time we move to the next one. In other words, guys, this is just calculating the length of the buffer. Once it is done, there is no more values, which means CL is going to be 0. And the reason CL is going to be 0 is because when fgets reads the value that we enter, it's going to put a 0 at the end, because a 0 in a string says it is the terminating character, so that the operating system knows that the string reached the end. Okay, once this loop is done, we are going to say, okay, EAX move specific values, subtract EDX, which was supposed to point to the beginning of the buffer, and then EX is going to have the length. A little bit confusing, guys? Don't worry, let's do something right here so that you can understand what I'm saying. I mean, it's practice only. So let me explain you here. So basically, we have here, right, our buffer that we enter, right? If you remember, we enter C, S, T, T, right? That's gonna be saved by fgets, and then when we click enter, also the enter is saved into the buffer, which is this guy, right? And finally, fgets is gonna put a 0 saying this is the end of the string. Then EAX says I'm here, right? I am EAX pointing here. And then it says the loop that we just saw says, hey, EAX, are you 0? No, fine, move to the next one. But let's say that here EAX was 40, right? Let's assume it was pointing to the address 40. So it says move forward, it's 41. Is it 0? No, next one. 0, no, next one. 42. Next one, 43. Next one, 44. Next one, 45. Hey, wait, it is 0. But then EX is finally incremented one more time. So at the end, EAX is going to be 46, right? It's going to find the 0 as you wanna get out of the loop, as we saw here. Hey, it is 0? Yes, it is 0 now. So get out of the loop. Once it is out of the loop, it's gonna subtract EX with EDX. But EDX was pointing to EX plus 1. In other words, EAX was pointing right here, guys. Right here. Which means EDX was 41. So once it is done, it's gonna say, hey, 46 minus 41, it is equal to 5. That way it knows that it has 1, 2, 3, 4, 5 values entered. Okay, guys? That's exactly this loop. So here, EX is gonna contain 5. So let's confirm that. Always confirm what you are learning, guys. So let's go here. We get into the loop. You see EAX, guys. In this bar is pretty useful because it's gonna tell you the values. So you can see that EAX, it says C in this point, which is gonna be copied to CL. CL, you will see that it's in A4, is gonna copy C, which means it is the letter 63 in hexadecimal. Okay, so we see the 63 there, it is being copied, and then increment EAX. Obviously EAX here is not 40, the address that I just explained is a different address, but the concept is the same. Then it says, hey, CL, which is just 1 byte, in this case C3, it is 0? No, it's not. That means move. And another thing here, guys, increment, and then this CL. If it is 0, here is the 0 flag, guys, okay? If it is 0, the 0 flag is gonna be set, which means it's gonna be changed to 1. So that when we go to the jump not 0, it's gonna check if the flag is not set, and if it is not set, it's gonna jump. But if it is 1, it is set, it's not gonna jump, and that's the way it knows how to get out of the loop, right? So it's gonna be set only when there is a 0 value. So we keep going, keep going, and eventually EAX is moving here the line feed, which is 08. 08, guys, is the line feed. This enter that we are seeing here, the hexadecimal value is 0A. Okay, that's important for you to know. Okay, so there is copying that one, and then after that you can see that EX is gonna move 0, right? It moves the 0 to CL, and then when it is gonna do the test CL, check the 0 flag right here, guys. It's gonna analyze it and say, hey, wait, the value is 0, CL is 0, then the flag is set, and then the jump not 0 or not equal or not flag set is not gonna take the jump because it's already set, and we get out of the loop. Then we subtract those addresses and we get EX equal to 5. Okay, guys, so this whole thing that we just saw is just a length. It's just to get the length of the string. But by practicing, you will realize this, guys, and you will get up to speed. So don't worry about that. Okay, so that is that. And then after that, we are right here after the loop, and we can see here that EX holds string past enter size, for example, right? So we can document those things. We click save. Okay, so now see this, guys. EX, sorry, it's gonna be comparison to 0A. If you remember, 0A is the enter. So basically what it's gonna say here is that if the last value is 0A, compare, and if it is not 0A, go over, but if it is 0A, it's gonna move to that specific offset CL. Okay, what we are seeing here, guys, is that EX, as you remember, it was pointing to the beginning, right? Sorry, it was pointing to a number, but then here again EX is reassigned, guys, and here this EX is gonna point to the end of the buffer. And I know that it is hard to understand, but we are gonna see it in the debugger in a second. So basically, what it is doing here is gonna say EAX move to the last value, which is right here, and tell me if you are 0A. If you are 0A, I need to remove this guy because it is not part of the password. It's just the enter, right? They need to remove it and put 0. That's exactly what is going on here. So let's see how that works in the debugger, because it's kind of hard to follow in either. So we come here and you check that it just compared this value, and I just step into it. Let me go back again, new origin here, you will just come back. So it's gonna say compare. Okay, so in this scenario you can see the value there. You can just quickly go here and say dd ESP plus EAX, sorry, ESP plus EAX plus 37. Okay, and we get exactly the same address that they are pointing to, which is 0A, which means these guys are the same. That's why the 0 flag was set, as you can see here. But I just wanted to execute it again to show you. So I execute again. So the 0 flag is set. Then the EX is going to point to a different address. Let's see what is that address. So EX is going to point also to that place. You see, EAX is pointed to the end of the string. If we go a little bit up in the memory, you can see that we have the CSTT, and then we have the 0A and 00. Okay, so now EX is pointing right there. Why? Because since we found it, it's gonna move CL, which is in this case 0, to EX. In other words, it is putting a 0, so that it is just removing the enter. Now we have the terminated string, which is null, so that we can only hold the CSTT password. Okay guys, that's exactly what happens here. So when we initialize it, we remove the 0. So now we have only the password that we received. That's the whole thing. Then we have another mem set. Okay guys, then here we have another weird calculations that can be kind of difficult for you guys to understand, but we can focus on here.